Hello, and welcome to tonight's Space Sleep Story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight we embark on a journey back to October 4th, 1957, the moment humanity first touched the cosmos. We'll explore the complete story of Sputnik, a simple silver sphere that transformed our world forever, igniting the space age and reshaping human civilization. So, settle into your most comfortable position, close your eyes, and prepare to witness history's greatest technological leap. Before we begin, let us prepare your body and mind with gentle breathing. Take a slow, deep breath with me now. Inhale gently for 4 counts. Hold the peace. Exhale for 6. Feel your body releasing into stillness. Let the tensions of your day dissolve with each breath. Your shoulders soften, your jaw relaxes, your mind grows calm. We have all night to rest. Another gentle breath as we continue our preparation. This time, notice how your chest rises and falls, how air flows effortlessly through you. Breathe in the vastness of space itself. Hold this peaceful moment. Exhale the noise and hurry of the modern world. With each breath, you release a little more into relaxation, sinking deeper into comfort. Let my voice be your guide through history tonight. Everything else can wait. October 4th, 1957. The autumn evening descends over the Kazakhstan steppe, where the Baikonur Cosmodrome sits in isolation, far from cities, far from scrutiny. At 10:28 p.m. Moscow time, the world changes forever, though most of humanity doesn't know it yet. A rocket designated R-7 Semyorka stands on its launch pad at Site 15, now known as Gagarin Start. 29.17 meters tall, weighing 267 metric tons, fueled with kerosene and liquid oxygen. But to understand this moment, we must step back through the shadow of the Cold War. World War II has ended 12 years earlier, leaving two superpowers facing each other across ideological chasms. The United States and Soviet Union raced to develop intercontinental ballistic missiles, weapons that could deliver nuclear warheads across continents in minutes. The arms race intensifies through the early 1950s. Yet within this competition, a few visionary engineers see another possibility. If a rocket can carry a warhead 5,000 miles, it can also carry something into orbit. In 1955, President Dwight Eisenhower announces on July 29th that the United States will launch an artificial satellite during the International Geophysical Year, July 1957 through December 1958. The announcement is public, optimistic, part of peaceful scientific cooperation. The Soviet Union responds quietly, their plans hidden behind layers of secrecy. Few in the West know the name Sergei Korolev, the brilliant mind orchestrating the Soviet space effort. His identity remains a state secret. He is known only as chief designer. Sergei Pavlovich Korolev was born January 12, 1907, in Zhytomyr, Ukraine. As a young man, he fell in love with aviation and rocketry, designing gliders and dreaming of spaceflight. But in 1938, during Stalin's purges, Korolev was arrested on false charges of treason. Interrogators beat him so severely they knocked out his teeth. He was sentenced to 10 years in the Kolyma gold mines, the most brutal labor camps of the Gulag system. Somehow, miraculously, he survived. By 1944, Soviet authorities recognized they needed Korolev's expertise for rocket development. He was transferred to a Sharashka, a secret prison design bureau where scientists worked under guard. After Stalin's death in 1953, Korolev was finally rehabilitated and rose to lead the Soviet rocket program. Yet the scars remained, physical and emotional, driving him with relentless determination. He would create spaceflight, no matter the obstacles, no matter the cost. His colleagues remembered him saying, "We will create spaceflight regardless of the paths of history." Throughout 1956 and 57, Korolev's team develops the R-7 rocket. It stands as tall as a 10-story building, powered by a central core engine plus 4 strap-on boosters, 5 engines total, containing 32 combustion chambers. At liftoff, it generates 3.92 million newtons of thrust, 880,000 pounds of force. The first successful test flight occurs August 21, 1957. The R-7 is officially the world's first intercontinental ballistic missile. But Korolev sees beyond weapons. The satellite itself is remarkably simple by necessity. Korolev had planned a sophisticated scientific satellite weighing over 1,000 kilograms, filled with instruments. But development delays and political pressure force a change. Instead, they build the simplest possible satellite, something that can launch quickly and prove the concept. 58 centimeters in diameter, about the size of a beach ball. Weighing 83.6 kilograms, 184.3 pounds. A polished sphere of aluminum, magnesium, titanium alloy, just 2 millimeters thick, gleaming like a mirror to reflect sunlight. Four whip antennas spring from the sphere, each 2.4 to 2.9 meters long, designed to extend once in orbit. Inside, pressurized with nitrogen gas to 1.3 atmospheres, sits a radio transmitter. 2 frequencies, 20.005 MHz and 40.002 MHz. The transmitter will broadcast a simple pulse, beep beep beep, lasting 0.3 seconds with 0.3 second pauses. Battery power for 21 days. That's all. Simple, elegant, achievable. They name it Sputnik, Russian for traveling companion. Alongside Korolev work other brilliant minds whose names remain hidden. Mstislav Keldysh, the mathematician calculating orbital mechanics with precision. Mikhail Tikhonravov, who first proposed artificial satellites in the early 50s. Valentin Glushko, chief engine designer, a former friend of Korolev, whose denunciation during Stalin's purges contributed to Korolev's arrest, creating lifelong tension between them, despite their collaboration. These men work in secrecy, their achievements attributed only to collective Soviet science. No individual names in newspapers, No public recognition, only the work itself. Now we arrive at October 4th, 1957. The R-7 rocket stands on the launch pad at Baikonur, Site 15, in the vast emptiness of Kazakhstan. Engineers complete final checks throughout the day. Fuel tanks fill with kerosene and liquid oxygen, the cryogenic oxidizer venting white vapor in the autumn air. Sputnik sits atop the rocket, secured, but ready for separation once in space. Korolev oversees everything personally, moving between bunkers and control rooms, checking calculations, reviewing systems. Years of work compress into these final hours. Evening arrives over the steppe. Sunlight fades to twilight, then darkness. Stars appear overhead, those eternal lights humanity has gazed upon since the beginning of consciousness. Tonight, humanity will join them. At 10:28 p.m. Moscow time, precisely 22 hours, 28 minutes, 34 seconds, the command is given. 32 combustion chambers ignite simultaneously. The ground shakes. Fire erupts beneath the rocket. Slowly, massively, the R-7 lifts from the pad, rising on a column of flame. "267 metric tons rise into the night sky. The roar echoes across the empty steppe. Watching engineers shield their eyes against the brightness. The rocket climbs, accelerates, punches through the atmosphere with increasing speed. The strap-on boosters separate as planned. The central core continues, pushing higher, faster. Orbital velocity approaches 28,800 kilometers per hour, 18,000 miles per hour. At the precise moment, explosive bolts fire. Sputnik separates from the rocket's final stage. Springs push the 4 antennas outward from the sphere. They extend to their full length, trailing behind like whiskers. The radio transmitter activates. Beep, beep, beep. The signal transmits at 20.005 MHz and 40.002 MHz simultaneously, a simple pulse traveling at the speed of light in all directions. Sputnik has achieved orbit. Perigee, its lowest point, 215 kilometers above Earth's surface. Apogee, its highest point, 939 kilometers. Orbital period, 96.2 minutes. Ground stations across the Soviet Union train their antennas skyward. Receivers lock onto the frequencies. Beep, beep, beep. The signal comes through clearly, unmistakably. A voice from space itself. Celebration erupts in the control bunkers. Engineers embrace, some weep openly. Korolev allows himself a moment of relief. Years of pressure, fear of failure, the weight of Soviet expectations, all release in this moment. They have done the impossible. They have placed an artificial moon in the heavens. But the signal doesn't stop at Soviet borders. Radio waves continue spreading, crossing mountains and oceans, reaching receivers worldwide. At 8:07 p.m. Eastern Time, an RCA receiving station in upstate New York picks up an unusual signal. Engineers verify the frequency, confirm the characteristics. Beep, beep, beep. They check and recheck, unable to quite believe what they're hearing. Word spreads through telephone lines. Scientists at universities, amateur radio operators, military facilities, all turn their antennas upward. All hear the same thing. Beep, beep, beep. Sputnik completes its first orbit. 96.2 minutes after launch, it passes over Baikonur again, still transmitting faithfully. The sphere is visible to the naked eye for anyone in the right location at dawn or dusk. Sunlight reflecting off its polished surface, a bright, moving star. Optical tracking stations follow it across the sky. Amateur moonwatch teams, organized volunteers with telescopes, spot it and report positions. The entire world becomes aware simultaneously. Radio Moscow makes the official announcement. TASS news agency releases the statement. The first artificial satellite of Earth has been created. This achievement opens the way to interplanetary travel. The words echo through news services worldwide. October 5th dawns across time zones, and newspaper headlines scream the news. In America, Red's launch moon appears in bold type. European papers marvel at the achievement. Asian newspapers report comprehensively. By midday October 5th, perhaps 80% of Earth's population has heard of Sputnik. The space age has begun. Nothing will ever be quite the same. Beep, beep, beep. The signal continues, orbit after orbit. Sputnik circles Earth every 96.2 minutes, 16 times per day. Scientists worldwide study the signal, analyzing its Doppler shift to calculate orbital parameters with increasing precision. The signal's passage through the ionosphere reveals information about atmospheric density at high altitudes. Radio propagation characteristics become clearer. Geodesists use tracking data to refine understanding of Earth's shape and gravitational field. Even this simple satellite produces valuable science. Sergei Korolev returns home in the early hours of October 5th, exhausted, triumphant, yet unable to claim public credit. His name remains secret. State security considers his knowledge too valuable to risk. Newspapers credit the achievement to collective Soviet science, to the superiority of socialist organization. Korolev can tell his family, his close colleagues, but the world will not know his name during his lifetime. He accepts this burden. The work itself matters more than recognition. The work continues. News reaches Western Europe as October 5th morning arrives. Britain's scientific community expresses admiration and surprise. French newspapers emphasize peaceful scientific achievement. In Asia, Chinese media praise Soviet technological prowess. Japanese scientists tune receivers to hear the beeping themselves. Indian press coverage is extensive and positive. Australian tracking stations in the southern hemisphere confirm orbital passage. Even Antarctica's research bases pick up the signal. The whole world listens to the same sound. Beep, beep, beep. United States, October 5th brings shock and soul-searching. President Eisenhower maintains public calm, stating he is not surprised, emphasizing that American satellite programs continue on schedule. But Congress reacts with alarm. If Soviet rockets can place satellites in orbit, they can deliver nuclear weapons to American cities. The military implications seem staggering. Senator Lyndon Johnson, future president, declares, "Control of space means control of the world." He warns, "Soon they will be dropping bombs on us from space like kids dropping rocks onto cars from freeway overpasses." Another Senate leader captures the strategic shift. The Roman Empire controlled the world because it could build roads. Later, the British Empire was dominant because it had ships. In the Air Age, we were powerful because we had airplanes. Now the communists have established a foothold in outer space. The metaphor resonates powerfully. Space becomes the new frontier, the new domain of competition and control. America's sense of technological superiority, built through World War II and sustained through the 50s, suddenly feels threatened. The American scientific community responds with mixture of emotions. Many scientists congratulate their Soviet counterparts publicly, recognizing the achievement's magnitude. But privately, concern grows about U.S. program delays. The Vanguard project, America's primary satellite effort, faces technical challenges and modest funding. Vanguard's planned satellite weighs just 1.47 kilograms, barely 1/50th of Sputnik's mass. This reveals the truth everyone now recognizes. Soviet rockets are far more powerful. Their engineering more advanced than American intelligence estimated. Amateur radio operators worldwide become part of the story. They share frequencies, coordinate observations, publish tracking predictions. Moonwatch teams organize viewing parties, gathering at dawn and dusk to spot Sputnik crossing the sky. Communities gather in parks and open fields, looking upward together. Children ask parents what it means. Teachers explain orbital mechanics in classrooms. The collective human gaze turns spaceward. For many people, this represents the first time they truly comprehend that space is accessible. Not theoretical, not distant future, but real and present. Beep, beep, beep. The signal continues day after day, orbit after orbit. Sputnik circles Earth faithfully. Its batteries are designed to last 21 days. Scientists measure the interval precisely. 0.3 seconds of beeping, 0.3 seconds of silence, repeating endlessly. The rhythm becomes familiar to millions. Some find it eerie, this voice from the void. Others find it beautiful, proof of human capability. Most simply listen with wonder. In Moscow, Nikita Khrushchev begins to grasp Sputnik's propaganda value. Initially, he showed little interest in the space program, viewing it as expensive and uncertain. But watching Western reaction, seeing newspaper headlines worldwide, he recognizes a victory. He praises Korolev publicly, though still without naming him. The chief designer has created a magnificent gift for the nation, Khrushchev announces. and he makes demands. Launch again soon. Make it bigger. The November 7th anniversary of the Bolshevik Revolution approaches. Create something even more spectacular. Korolev's team faces intense pressure. They have just weeks to prepare a second mission. The second satellite, Sputnik 2, will be far more ambitious. 508 kilograms, more than 6 times heavier than Sputnik 1. And it will carry a passenger, a living creature to test whether life can survive launch and weightlessness. A small dog named Laika. Korolev knows the technology for safe return doesn't exist yet. This will be a one-way journey. But the mission proceeds. Meanwhile, Sputnik 1 continues its faithful orbit. October passes into November. On October 26th, after 21 days, the transmitter batteries finally exhaust. The beeping stops. But Sputnik remains in orbit, a silent sphere circling Earth. Tracking continues through optical observations. Gradually, imperceptibly, atmospheric drag begins to slow the satellite. Each orbit decreases slightly in altitude. The process will take weeks. November 3rd arrives. Exactly 30 days after Sputnik 1, Sputnik 2 launches from Baikonur. The larger satellite reaches orbit successfully. Laika's vital signs transmit to ground stations, confirming she survived the violent acceleration of launch. Her heartbeat, breathing, body temperature, all monitored continuously. The world learns that a dog orbits Earth. Reactions mix wonder and controversy. Animal welfare advocates protest the one-way mission. Soviet media presents Laika as a hero. Laika survives approximately 5 to 7 hours in orbit. Overheating and stress eventually end her life. But her mission provides crucial data. Life can survive launch forces. Living organisms can function in weightlessness. The path toward human spaceflight becomes clearer. Decades later, memorials to Laika appear in Moscow and elsewhere. A small statue honors her sacrifice. Her story becomes part of space history's complex legacy. In the United States, urgency builds throughout November and December. The Vanguard program prepares a launch attempt. December 6th, Vanguard TV-3 sits on its pad at Cape Canaveral. The slim rocket stands ready. Countdown proceeds smoothly. Ignition. The rocket rises approximately 4 feet. Then it settles back, crumples, and explodes in a massive fireball. The tiny satellite rolls clear, its transmitter mockingly beeping amid the wreckage. American newspapers show no mercy. Headlines coin cruel nicknames. Flopnik, Kaputnik, Stayputnik. The failure becomes a national embarrassment, compounding the shock of Sputnik. But it forces a change in strategy. The Army's Jupiter C program, led by Wernher von Braun's team of former German rocket scientists, gets approval to attempt a launch. Von Braun's team works frantically through January. January 31st, 1958, Explorer 1 successfully reaches orbit. America has its first satellite. Explorer 1 weighs just 13.97 kilograms, but it carries sophisticated instruments designed by James Van Allen. Within weeks, Van Allen's team analyzes the data and discovers radiation belts surrounding Earth. The Van Allen belts become the first major scientific discovery of the space age. American pride recovers somewhat. The space race has truly begun. Both nations committed now to the competition. The political response in America becomes comprehensive. On February 7, 1958, President Eisenhower signs the order creating DARPA. The Defense Advanced Research Projects Agency will pursue advanced military technology. On July 29th, NASA is founded. The National Aeronautics and Space Administration absorbs the old NACA, the National Advisory Committee for Aeronautics, and gains a bold new mission. Explore space. Land humans on the moon. Demonstrate American capability. Education reform sweeps America. September 2, 1958, the National Defense Education Act becomes law. $1 billion allocated for science and mathematics education. A staggering sum for that era. Schools add advanced science courses. Universities expand engineering programs. Scholarships and fellowships encourage students toward technical careers. An entire generation's education shifts in response to Sputnik's beeping signal. The effects ripple through decades. Sputnik 1 continues its silent orbit through the autumn and early winter. Atmospheric drag gradually lowers its perigee. Each orbit decreases the altitude slightly. The process accelerates as the satellite descends into denser atmosphere. On January 4, 1958, exactly 92 days after launch, Sputnik's orbit finally decays completely. The sphere enters the atmosphere at orbital velocity. Friction generates tremendous heat. The aluminum-magnesium-titanium alloy glows, melts, vaporizes. Sputnik burns up over the Pacific Ocean. (1,440 orbits completed, 92 days circling Earth. A simple sphere, 58 centimeters across, weighing 83.6 kilograms. Nothing complicated, nothing sophisticated by later standards. Yet it changed everything. Human civilization divided into before Sputnik and after Sputnik. The space age began with that beeping signal. Every satellite since owes its existence to that first orbit. Every space station, every planetary probe, every astronomical observatory, all children of Sputnik. Sergei Korolev continued his work through the 1960s. He sent the first human to space, Yuri Gagarin, on April 12, 1961. He planned missions to Venus and Mars. He designed the Soyuz spacecraft. But on January 14, 1966, Korolev died during routine surgery. He was 59 years old. Only after his death did the Soviet Union reveal his identity to the world. Only then could he receive the recognition he deserved. Only then could history speak his name. legacy of October 4, 1957 continues. International cooperation in space eventually emerged from Cold War competition. The International Space Station today hosts crews from many nations working together. American astronauts launch on Russian Soyuz rockets. Russian cosmonauts live aboard modules built by the United States. The rivalry that began with Sputnik evolved into partnership. Both nations, former adversaries, now friends in the cosmos. On October 4th each year, space agencies worldwide commemorate Sputnik's anniversary. World Space Week celebrates the achievement. Museums display replicas of the polished sphere. Recordings of the beeping signal play for new generations. Children learn about Korolev's perseverance, about overcoming impossible odds. They learn that humanity can achieve extraordinary things, that boundaries can be crossed, that space itself can become accessible. Consider all that followed from that first orbit. Humans walking on the moon, rovers exploring Mars, probes visiting every planet in our solar system, telescopes revealing galaxies billions of light years distant, communication satellites connecting every corner of Earth, weather satellites saving countless lives through storm prediction, GPS navigation, satellite television, global internet, Earth observation, all descendants of Sputnik. All made possible because someone dared to place a simple sphere in orbit. The beeping lasted only 21 days, but its echo continues forever. In every rocket launch, we hear that echo. In every orbit achieved, every mission accomplished, Sputnik's signal became humanity's declaration. We are spacefaring. We are explorers. We reach beyond our birth world. Imagine that autumn evening in 1957, stars overhead, the same stars humans had gazed upon for millennia. Then a new light appears, moving steadily across the sky. Not a star, not a planet, but something humanity created. That moment of recognition, that understanding that we had changed our relationship with the cosmos. No longer bound entirely to Earth's surface, now reaching outward. Sergei Korolev dreamed of this throughout his suffering. In the Kolyma gold mines, in the Sharashka prison bureaus, through all the humiliation and pain, he held the vision. Humanity traveling to other worlds. He lived to see the beginning. Sputnik orbiting, Gagarin circling Earth. The foundation laid. He died before the moon landings, but his work made them possible. The polished sphere, aluminum, magnesium, titanium alloy, 2 millimeters thick, 58 centimeters across, 4 spring-mounted antennas, a simple radio transmitter, nothing complex, nothing impossible, just engineering, determination, vision, and it transformed human civilization. Every 96.2 minutes, another orbit completed. circling Earth, beeping faithfully, a traveling companion. Sputnik, humanity's first step into infinity. The signal has stopped, but the journey continues. Every satellite we launch honors that first achievement. Every person who looks up at the night sky and sees satellites passing overhead. Part of Sputnik's legacy, part of humanity's expansion. October 4th, 1957. The date when everything changed. The boundary crossed. The space age begun. Peaceful achievement. Human capability demonstrated. The cosmos welcoming us. Rest now in the knowledge of what humans can accomplish. Against impossible odds, through suffering and perseverance, with vision and courage, we can reach the stars. The orbit continues, circling peacefully. 96.2 minutes. Regular as breathing. Constant as the stars. Beep, beep, beep. The echo in memory, forever reminding us, space is possible. Traveling companion, Sputnik, orbiting in history, orbiting in dreams. (1,440 orbits, 92 days, but its influence eternal. The polished sphere, reflecting sunlight, visible at dawn, visible at dusk. A bright, moving star, created by human hands, placed in the heavens. 58 centimeters, 83.6 kilograms. Infinite impact. Rest now as Sputnik rested, circling peacefully, part of something greater. The space age has begun, and we are all travelers. Orbiting together through the cosmic night. Lesson just as I am's, listen to essential that a number one, hoopened, I want to the same time, which was noli se. Beep, long pausive, beep, beep, pausive. October 4th, 1957. Forever remembered. The stars above, the earth below. Sputnik's gift. The cosmos opened, the gift. "96 minutes, one orbit, eternal journey." Traveling companion, guiding us homeward. Rest in the achievement, sleep in the wonder. Rest in the achievement, lest in the fast. weeping fades, but peace remains. Circling, orbiting, floating. Space embraces us. Sleep now. Space embraces us if we listen to it. Sputnik dreams. We dream. October 4th, forever peaceful. The stars watch over. Rest deeply. This is not daily. The new one stars of the stars, the new one stars, do not givenly. 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 Traveling companion. Sleep companion. Beep, sleep. Orbit complete. Journey peaceful. Dawn of the space age. Dawn of dreams. Rest now. Sputnik rests. October 4th, Eternal Peace. I find us to discover the death with killers of life. The cosmos calls. Sleep answers. Korolev's dream, your peaceful rest. '57, forever changed. The first satellite, the first step. Orbiting Earth, orbiting dreams. Space opened, sleep deepens. Sputnik sleeps. You sleep. Peace above, peace within. Dawn comes. Rest continues. Dawn. Good night. Sleep well. Sleep well. Please lest. No book. Sleep well herever. The sphere orbits. You rest. History made. Dreams continue. Don't look to start weather yet. Content let a lower renning from keep. To store this officially, thus panglet. Testifall such a case of likin comes to into it. Thier lesting Ruben technology. You're given this rester, and you Korolev's vision. Your peace. Satellite above. Sleep below. All is well. All is peaceful. Sputnik. Sleep. rest. October night, forever peaceful. Orbit, dream. Space, peace. Stars, sleep. Circling, resting, long pause. Floating, sleeping. That's okay, want her, do your noticed. You have to leved, you have to leved, you have to leved, you have to leved. Dawn. Rest. We know that, we sensed. Journey. Dream. Sputnik sleeps. Sleep now. Forever peaceful. Forever peaceful. Good night.